Hi everyone, in today's video, I am excited to share with you a fascinating topic in algebra, and this is what we call the arithmetic sequence. An arithmetic sequence is a sequence of numbers in which the difference between any two consecutive terms is constant. This constant difference is called the common difference. Let's look at an example of an arithmetic sequence: 2, 5, 8, 11, 14. In this sequence, notice that the difference between each consecutive term is constant. 5 minus 2 equals 3. 8 minus 5 equals 3. 11 minus 8 equals 3. 14 minus 11 equals 3. So this constant value is called the common difference, and in this case, it's 3. Finding the nth term. To find any term is an arithmetic sequence, we use the formula a sub n equals a1 plus n minus 1 d, where an is the nth number, the term we want to find. A1 is the first term of the sequence, d is the common difference, n is the position of the term in the sequence. Example, let's find the sixth term, n equals 6 of the sequence 2, 5, 8, 11, 14. First term, a1 equals 2, common difference equals 3, position equals 6. Substitute these values into the formula. So it will become a sub 6 equals 2 plus 6 minus 1 times 3. Simplify. A sub 6 equals 2 plus 5 times 3 equals 2 plus 15 equals 17. So the answer for the sixth term of the sequence is 17. This is how we use the formula of an arithmetic sequence to find any term in the series. Let's dive into an interesting historical trivia about arithmetic sequence. Did you know that arithmetic sequences were studied as early as ancient Greece? One of the most famous mathematicians, Pythagoras, used arithmetic sequences to explore musical harmonies and ratios. Pythagoras discovered that musical notes produced by strings of different lengths follow a specific pattern by dividing a string into equal ratios such as 1:2 or 2:3. He observed that the resulting sound created harmonious tones. Arithmetic sequences aren't just a topic in math class, they're everywhere in our daily lives. Let's explore some simple examples you might encounter every day. Climbing stairs. Have you ever noticed that each step of a staircase is evenly spaced? The height of each step increases by a fixed amount, forming an arithmetic sequence. For example, if each step is 15 centimeters high, the heights of the steps from the ground would be 15, 30, 45, 60, and so on. Saving money. Imagine you save 20 pesos every day. On the first day, you have 20 pesos. By the second day, you'll have 40, and by the third day, 60. Here, the amount you save increases by a fixed rate of 20 pesos per day, creating an arithmetic sequence: 20, 40, 60, 80, and so on. Bus stops and scheduling. If a bus arrives at your stop every 10 minutes, the times of arrival from an arithmetic sequence, for example, 0, 10, 20, 30, 40, so on, in minutes. In all of these examples, the key feature of an arithmetic sequence is that the difference between consecutive values is constant. Whether it's saving money, climbing stairs, or waiting for the bus, arithmetic sequences help us recognize patterns and plan our daily routines efficiently. And for the real-life examples, we're done in saving money, so let's proceed in the plant growth. Plant growth. A plant growing by the same height every week is an arithmetic sequence. Now let's look at a practical example of an arithmetic sequence using plant growth. Scenario: Imagine you're observing a plant that grows steadily by 3 centimeters each week. The plant starts at an initial height of 10 centimeters. How tall it will be after 5 weeks? Step 1. Identify the sequence. Let's calculate the height of the plant week by week. Week 1, 10 centimeters. Initial height. 10 plus 3 equals 13. Week 3, 13 plus 3 equals 16. Week 4, 16 plus 3 equals 19 centimeters. Week 5, 19 plus 3 equals 22. The sequence of height is 10, 13, 16, 19, 22. Step 2. Check the common difference. The plant grows by 3 centimeters each week, so the common difference, or D, is 3. For the step 3, use the formula of the nth term. To find the height at any week, or n, we use the formula for the nth term of an arithmetic sequence. An equals a1 plus n minus 1 times t. After you substitute the values, you need to simplify it to get the final answer. And after 5 weeks, the plant will be 22 centimeters tall.